Hello, in this lecture we will find the radius of a circle. In the drawing we have a circle, and inside the circle we have a square. The center of this circle is at point O. This 9 segments equals to 6 units, and this 9 segments equals to 3 units. First of all, we will define this point as point M. And this point will be defined as N. So actually, line segment MC equals to 6 units, and line segment AN equals to 3 units. Because of the fact that point O is the center of this circle, line segment OA is the radius, and also line segment OC is also the radius. So OA equals to OC. Okay, OA equals to OC. Both of them are radiuses of this circle. OA equals to OC. They are the radiuses of this circle. So our first equation is that OA equals to OC. OA equals to OC. Both of them are radiuses of this circle. But in the next step, we will define line segment ON as X, ON equals to X, and line segment MO will be equal to Y. According to our definition, line segment MO equals to Y. Okay, and we know that OA equals to OC. Both of them are radiuses of this circle. So actually OA is x plus 3. OA equals to x plus 3. So we can substitute OA in the first equation by x plus 3. And OC equals to y plus 6. So we can substitute OC by y plus 6. So we got equation number 1 that states that x plus 3 equals to y plus 6. Now we'll subtract 6 from equation number 1. So we subtracted 6 from equation number 1. X plus 3 minus 6 equals to x minus 3 plus 3 minus 6 equals to minus 3. So in total we have x minus 3, and y plus 6 minus 6 equals to y. So we have equation number 1 that states that y equals to x minus 3. Okay, so actually this is a square, and we know that one side of the square equals to y. So if one side equals to y, and the other side must be equal also to y. So side bn of the square is also y. Okay, so you can write here that this side of the square equals to y, but we know from equation number 1 that y equals to x minus 3, so we can add here that y equals to x minus 3. Okay, OB is the radius of this circle, so OB equals to OA. Okay, OB equals to OA, both of them are radiuses of the circle. OB equals to A, both of them are radiuses of the circle. OB equals to OA equals to R. OB equals to OA equals to R. So actually OA, that is the radius of this circle, equals to x plus 3. So OB, that is also the radius, will be equal also to x plus 3. Okay, so actually all of the angles inside the square equals to 90 degrees, so this angle BNO will be equal to 90 degrees because it is one of the angles in the right square, so it is equals to 90 degrees, and actually we have a right triangle. The green triangle is a right triangle, and we know that one side of this right triangle B and O equals to x minus 3, the other side equals to x, and the hypotenuse of this green right triangle equals to x plus 3. So we can use the Pythagorean theorem in order to find out the value of x. The Pythagorean theorem states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So that is to say, OB square equals to BN square plus NO square. Okay, so actually our second equation will be the implementation of the Pythagorean theorem in this right green triangle. So it is OB square equals to NB square plus ON square. So according to the Pythagorean theorem, we have the second equation that states the square of the hypotenuse, that is OB square, equals to the sum of the squares of the perpendiculars, equals to NB square plus NO square, equals to BN square plus NO square. Okay, but we know that OB equals to x plus 3, NB equals to x minus 3, and NO equals to x. Okay, so I will write it down so we can substitute. Okay, first of all I will write it down. OB equals to x plus 3, NB equals to x minus 3, and On equals to x. Okay, On equals to x, OB equals to x plus 3, and NB equals to x minus 3. Okay, so we can put the data inside the question number 2, and we will get that x plus 3 square equals to x minus 3 square plus x square. Okay, here in the second equation we substituted OB by x plus 3 because OB equals to x plus 3. We substituted NB by x minus 3 because NB equals to x minus 3, and we substituted NO by x because NO equals to x. So we got that x plus 3 square equals to x minus 3 square plus x squared. Now we will open the brackets in the second equation. So actually we open the brackets in this second equation. X plus 3 square equals to x squared plus 9 plus 6x, according to the equation that a plus b square equals to a square plus b square plus 2 times ab. X minus 3 square equals to x squared plus 9 minus 6x, according to the equation that a minus b square equals to a square plus b square minus 2 times ab. And x square, we copied it here, so here we actually have x square in both sides of the equation, so x square is cancelled. We have 9 in both sides of the equation, so 9 is cancelled. So we left only with here with 6x and here with minus 6x plus x squared. So I write it down. So here, in this side of the equation, what is left is only 6x, and in this side of the equation, what is left is minus 6x plus x squared. In the next step, we will take a common factor x from this side. First of all, we will subtract minus 6x from equation number 2. So we subtracted 6x from equation number 2. 6x minus 6x equals to 0, and 6 minus 6x minus 6x equals to minus 12x. So in total we got here minus 12x plus x. So we take a common factor x from the third equation, from the second equation. Again, we will take a common factor x from the second equation. We'll get that so we took a common factor x from the second equation. So in total we got that x, and inside the brackets we have x minus 12. So to this equation we have two solutions. X could be equal to 0, or x minus 12 equals to 0. X equals to 0 is impossible because it says that actually the square doesn't exist, and actually the square doesn't exist, so it is impossible that x equals to 0. The other option is that x minus 12 equals to 0. So if x minus 12 equals to 0, we'll add 12 to this equation. We will get that x equals to 12. X equals to 12. Okay, x equals to 12, and actually the radius of the circle equals to x plus 3. Okay, the radius equals to x plus 3. But x equals to 12, so we can write that the radius equals to x plus 3, that is to say to 12 plus 3. So actually the radius of the circle equals to 15 units. Again, the radius of this circle equals to 15 units. Okay, so now I will summarize the lecture, the short lecture. Actually, we wanted to find out the radius of this circle. Inside the circle, we have a square. Inside the circle, we have a square, and the center of this circle is at point O. Line segment MC equals to 6 units, and line segment AN equals to 3 units. We defined line segment MO as Y and line segment NO as X. Again, line segment NO is defined as X, and line segment MO is defined as Y. Okay? But we know that OA equals to OC, both of them are radiuses of the circle, okay? OA equals to OC because both of them are radiuses of the circle. But we know that OA equals to x plus 3 and OC equals to y plus 6, so we can substitute OA by x plus 3 and OC by y plus 6. Okay, so we got in equation number 1 that states that x plus 3 equals to y plus 6, and equation number 1 states that y equals to x minus 3. Okay, because of the fact that this is square, so if one side of the square equals to y, also the other side must be equal to y, because all the sides in a square are equal to each other. So if this side of the square equals to y, this side also must be equals to y. But y equals to x minus 3, so we can write here that this side of the equation equals to y, that equals to x minus 3. So actually we have the green triangle that is a right triangle, because this angle equals to 90 degrees, and in the right triangle we have one side that equals to x minus 3, the other side equals to x, and the hypotenuse is actually the radius of the circle, and the radius of the circle equals to x plus 3, because OA equals to OB equals to the radius of the circle, and the radius of the circle is x plus 3. So OB, that is also the radius of the circle, equals to x plus 3. We can use the Pythagorean theorem in order to find out the value of x. The Pythagorean theorem states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OB square equals to OBN square plus ON square. Okay, OB square equals to NB square plus ON square. Okay, so we found out that from the Pythagorean theorem and the second equation that the x equals to 12 units, but the radius of this circle equals to x plus 3. So the radius of this circle will be equal to 12 plus 3, that is 15 units. Okay, so the radius of this circle equals to 15 units. Okay, thank you very much.